Welcome to the lecture series of hydraulic structures. So, in the previous sessions, this is module 2, session 3. So, in the session 1, we had discussed about the earthen dams and the different types of earthen dams. In session 2, we discussed about the different components of the earthen dam. In this session, we are going to learn about the failures of earthen dam. What are the different failures of earthen dam? So, let me share the content and discuss each failure in detail. So, causes of failure of earth dams. So, there are the dams may fail due to the following reasons. One is the hydraulic failure. This is basically because of water overtapping on the dam, or maybe due to saturation on the upstream side and downstream side. The upstream side face will fail and the downstream side face will fail. All the reasons are due to water which is in directly contact with the dam, whereas this seepage is due to the seepage of water through the dam section, which may cause piping and many other reasons. And structural failure is basically because of the failure of the structure because of weak foundation or steep slopes. Such reasons are there for, or many such reasons are there for structural failure. So let us discuss each one in detail. So first let us take up hydraulic failure. 40% of the earth dams fail due to this reason. So the first one is because of overtopping of the dams. Overtopping of the dams. So we'll take the other one is erosion on the upstream side surface, erosion of the downstream surface, erosion of the downstream toe. So here we'll first take up overtopping of dams. So you can see here the top of the dam itself has been damaged here. The dam itself is damaged and the water is flowing through the dam which is cut. So why this happens? So during the design of the dam, some flood estimate would have been made. So if the flood estimate exceeds the design flood, sorry, if the flood exceeds the estimated flood, uh, and if the gates are not sufficient, we provide spillway gates. Spillway gates are nothing but the gates to allow the excess water in the dam to flow through from the upstream side to the downstream side. So it is like this. So if this is the dam section. Oh, okay. This is the dam section. Water will flow from here. The excess water will flow through the gates here. Gates will be provided at the crust level like this, and water will flow. Excess water will flow to the downstream side in this direction. So, if the gates are not sufficient, if you have not designed the gates properly, or the gates available are not sufficient, and if the flood exceeds the estimated flood, then what happens? Overtopping of the dam takes place. Water starts flowing over the top of the dam. And also, one more reason is due to insufficient capacity of the spillway. One is due to wrong estimate of the flood and insufficient freeboard. So we allow some freeboard above the maximum reservoir level. This is MW level. So above this we will see leave some freeboard. If the freeboard is not sufficient, so water flows over the top of the dam and it will cause failure. So that is called as overtopping of dams. Second one, this is caused due to wave action on the upstream side. So wave action See what happens is the wave which are created on the surface of water due to wind in the reservoir um, will lead to its slip. So this will cause saturation on the upstream side. So it keeps on hitting the dam. The waves will keeps on hitting the dam, and it will create some erosion here. Erosion here. So that will make the material, and because of that erosion, the material is lost. The material is lost and the dam will become weak, and this leads to slip of the material like this. You can see that here, and this can be avoided by protecting it from pitching. So if this is the top surface upstream side of the dam, this is the upstream side of the dam, and other dam will be like this. So here pitching should be provided with broken stones. The upstream surface should be protected properly. This is called pitching or riprap. So this pitching has to be provided in order to avoid this. So here you can see the pitching. If they are not properly provided due to wave action, the waves keep on hitting the material here, and then the material will get eroded, and the material will, and the surface will get slipped. So that is called erosion of the upstream surface. Next is erosion of the downstream surface. See, this is the downstream surface of the dam. You can see some gullies are formed. These are called gullies. This is basically because of rainwater, action due to rain. So when the rain comes, the rainwater will start flowing down the downstream side, and the gullies will be formed like this. So how to prevent this? This can be prevented by planting some harali. Harali is a type of grass which will be grown on this downstream side. So we have to plant harali to avoid this erosion of downstream face. So this is due to rain action. If this is not chucked properly, gullies are formed on the downstream face, ultimately leading to dam failure. To avoid this, planting harali on the downstream face and also by proper maintenance, the gullies can be avoided. Then erosion of the downstream toe, not the downstream face, toe. You know, this is the dam section, and this portion is called as a toe, and this portion is called as a heel. The upstream portion is called heel, and the downstream portion is called toe. So here there will be tailwater. This may be due to the water through the filter drain, or maybe when the spill gates are opened, the water will flow. The excess water will flow from the upstream side to the downstream side. So this tailwater will, erode the material near the toe here. So tailwater affecting the toe of the embankment. So here also you have to protect the toe. So the toe of the dam may be eroded due to heavy cross currents coming from the spillway bucket or tailwater. Spillway bucket is a device which is used for dissipating the energy of the flow from the spillways. I told you spillway is used to discharge the water from the reservoir to the downstream side, excess water. When the excess water flows from the upstream to downstream side, there will be high velocity. So because there is a gradient, there is a difference in height. So when the water flows from a higher height to a lower height, there will be velocity, high velocity. This energy, and there will be a lot of energy, and this energy will cause erosion here. So for that, we provide energy dissipating the devices to reduce the energy of water which is flowing from the spillway. Spillway bucket is one of the type of energy dissipator. So the one from the spillway bucket, the water will flow further. So this will cause cross currents and damaging the tailwater. Damaging the tailwater. We'll discuss the spillway buckets in detail in the coming sessions. The second type of failure is the seepage failure. So first type of failure is due to hydraulic failure. In hydraulic failure, one is due to overtopping, that is if because of wrong estimate of the flood, or if the spillway gates are insufficient, overtopping, or if the freeboard is insufficient, overtopping will take place. In the second case is due to erosion of the upstream side, that is because of wave action, erosion of the downstream side forming gullies, erosion of the toe, downstream toe, that is because of the tailwater currents. And the second type of failure is due to seepage. Here it is for 33% of the dam fail due to seepage, and 40% is because of the hydraulic failure. 33% is because of the seepage failure. All the earth dams have seepage resulting from water permeating slowly through the dam and its foundation. Permeating through slowly through the dam and its foundation. So we know earthen dam is made up of natural materials and independent particles. They are made up of almost pervious soils. Correct? Soils are pervious, so water will seep through the dams. Water will seep through the dams. This seepage must be controlled in both velocity and quantity. Okay, so seepage occurs. So seepage should be controlled in both velocity and its quantity. If the velocity is more, it will carry the materials along with the seepage water and causing cavities within the dam. It should be within the design limits, and if uncontrolled, it can progressively erode the soil from the embankment or its foundation, resulting in rapid failure of the dam. So, what happens? It will erode the soil from both the body of the dam, embankment, or its foundation also. If the foundation is again pervious, if it is made up of gravel and loose material like that, there also it will cause erosion of the material, resulting in rapid failure of the dam. So it is there are two types of seepage failure. One is piping through the dam and piping through the foundation. You can see here, this is piping through the body of the dam. A cavity has been formed. So if the seepage water carries this loose material along with it, it forms a cavity. Gradually, the size of the cavity will increase, and the water stops flowing through these cavities. This is called piping through the dam. So the same thing happens in the foundation also. So that is called piping through foundation. So it is due to transport of soil particles along with seepage flow. As I told you, only water will not be flowing. Along with the flow, or it will carry soil particles also. It results in gradual formation of drain from upstream to downstream, through which the water flows here. Actually, it doesn't seep, water flows, and then the dam fails. So piping through foundation. So here you can see piping through foundation. It is not through the body of the dam, it is through the foundation in this case. So it is a pervious foundation. So water start flowing from upstream side to the downstream side through the foundation. Here you can see piping through the body also, piping through the foundation also. Piping through the body is causing a cavity within the embankment. Okay. The third type of failure is the structural failure. The previous failure we discussed was due to seepage. In seepage, there are two types: piping in the embankment, piping in the foundation. So piping in the body of the dam means it will, along with the water, it carries the soil particles forming cavities. The size of the cavities will increase and water starts flowing through these pipes, through these cavities, which may be called as pipes. So it is called piping. And the same thing happens through the foundation. So it is called piping through the foundation. And this is structural failure. So the structure will fail if it is not properly designed. So failure of the upstream phase due to sudden drawdown. Due to sudden drawdown. Failure. So sudden drawdown means the water level will suddenly fall. So if the water is drawn all of a sudden with a force, then the water level will drop suddenly from a higher level to lower level. During that case, this upstream phase will fail due to upstream and downstream side slope. If the side slopes are not properly designed, then it will fail. Damage due to burrowing animals. Some animals will burrow their homes inside the earth. So if they burrow the animals, that will result in forming cavities and they fail. Failure of dam due to earthquake. So earthquake, a failure will be there. Because of earthquake, there will be vibrations. It may cause a sliding of the dam at the base, that is shear failure, or the foundation might fail, or the embankment may crack, or the waves, it will generate high waves in the water, so that due to wave action it may fail. So the various reasons for this earthquake failure. And faulty construction and improper maintenance. If during constructions, if it is not compacted, because earthen dams are built by placing layers one over the other and by compacting them at optimum moisture content. If it is not done properly, it will happen. And improper maintenance, if the pitching is eroded, so you have to re-pitch the upstream side, or on the downstream side, because of rain, if gullies are formed, it has to be again repaired. And this harali has to be maintained on the downstream side. So if all this is not done, the structural failure will takes place. So the first one is due to sudden drawdown. You can see here, this is the dam section, this is the upstream side, this is the initial water level, this is the rapid drawdown due to sudden discharge of water from the upstream to downstream side. There will be rapid drawdown. So this part of the water, this part of the dam will be saturated on the upstream side. Because of the presence of water, if there's sudden, there will be sliding like this. There will be sliding of the material, and the structure will fail. The material on the upstream side will suddenly come down. Okay. And then failure of upstream phase due to sudden drawdown, I already explained it to you. Failure due to upstream and downstream slope slide. The slopes being steeper than required leads to slip due to stress. So here you should have a flat slope. You should have a flat slope, not a steep slope. So the section should not be steep like this. It should be flat. So if it is flat, it is more stable. If it is steep, what happens? It leads to slips due to stress. The slopes should be flat as required from the structural point of view. So these flat slopes are more stable compared to steep slopes. So you have to design the slope as required. Burrowing animals. So small animals living in the holes may dug their holes anywhere in the dam body, which may widen with the passage of time and can be dangerous. So due to earthquake, I told you that many causes. One is the cracking of the dam may take place, and the may cracking of dam top may happen, the central core may crack, settlement of the dam may happen because of settlement of the foundation, shear failure at the base, the whole dam may slip, and overtopping due to high waves generated in the reservoir, because it causes vibration in the water also. So these are all the different failures of dam. Thank you. So, in this session, we discussed the different types of failures of dam. One is the hydraulic failure, second one is a seepage failure, third one is a structural failure. In each failures, there are different causes, so which we have discussed in detail. Thank you for listening. So, let's end this slideshow.